Every single time you click a link, load a page, or watch a video online, there's a secret conversation happening. It's happening in the background, a language that powers the entire web. And today, we're going to decode it. We're pulling back the curtain on the protocol that makes it all possible, the Hypertext Transfer Protocol, or, as you probably know it, HTTP. Right. It stands for Hypertext Transfer Protocol, but that's just a fancy name. What it really is the fundamental language of request and response that lets your computer talk to the servers hosting all the websites you love. You are, no joke, using it this very second to watch this.
So the best way to wrap your head around HTTP is to think of it like a really simple, super-structured conversation. And like any conversation, you need at least two people, or in this case, two machines. Let's meet the two speakers, the client and the server.
First up, we've got the client. And for all practical purposes, this is you. Or to be more precise, it's your web browser, Chrome, Firefox, Safari, whatever you're using. When you type in a web address, your browser becomes the client, and it sends out a request basically shouting into the void, "Hey, can I please have this web page?" And on the other end of that line, listening for that request, is the server. This is a powerful computer whose entire job is to just sit there and listen for clients asking for stuff. When it gets a request, it finds the information, an article, an image, a video, and sends it back. That's it. The simple back and forth, a request and a response, is the beating heart of everything you do online.
Okay, now here's where this conversation gets a little weird. It has one really important, kind of strange rule. It's stateless. And what that means is the server has the memory of a goldfish. By design, it completely forgets who you are the second your request is over.
Think of it like this. A stateless protocol like HTTP is a vending machine. You put your money in, you press B4, you get your chips. The machine has no idea who you are or what you bought 5 minutes ago. Every single time, it's a brand new transaction. Now compare that to a stateful protocol like, say, FTP, which is more like a phone call. The connection stays open, and both sides remember the context of the conversation. So why would the web be built on this forgetful foundation? Well, it comes down to one word: scale. By treating every request as a totally new event, any server in a massive global network can answer it. It makes the web unbelievably robust and able to handle billions of us all at once. So, if the client is making a request, what does that request actually look like? It's not just asking for a website. It's incredibly specific, and all those specifics are packed into something you use every single day: the URL. Let's just grab this example from our source material. Now, at first glance, this might look like a jumble of characters, but it's not. It's actually a perfectly structured set of instructions for the server. Let's break it down, piece by piece. First, we've got the scheme, HTTPS. This part tells the browser which rulebook to use for the conversation. And that's really all a protocol is, a shared set of rules. In this case, that little S on the end is super important. It stands for secure, which means our whole conversation is going to be encrypted. Next up is the host, theartofhacking.org. This one's pretty straightforward. It's the address of the server we want to talk to. Think of it as the street address for the website's house. Your browser uses this to find the exact computer it needs to talk to out of the billions on the internet. Now this part is pretty interesting, the port, which here is :8123. If the host is the building street address, the port is like a specific apartment number or door. Most of the time, websites use default ports, like 80 for HTTP, so you never even see them. But this URL is telling the browser to knock on a very specific custom door. Okay, so we've arrived at the right building, we've gone through the right door. Now we need to find the specific room we're looking for. That's the path, /dir/test. This tells the server exactly which file or resource we want from its vast collection of files. And finally, we have this bit at the very end that starts with the question mark. This is the query string. This is just extra information we're giving the server. It's like filling out a little form. Here, we're saying the name should be Omar and the value X should be true. This is what allows for all sorts of dynamic content all over the web. So the URL tells the server what we want and where to find it, but the request is missing a verb, an action, to say what we want to do. Almost every time you're just browsing, your browser sends a GET request. It's literally just asking to get information. But when you fill out a contact form or log into a site, your browser sends a POST request, which posts your data to the server. And as you can see, there are others like put and delete, which do pretty much what they sound like. All right, The client has carefully put together this very specific request and sent it on its way. Now we've got to look at the other half of the conversation, the server's reply. And the single most important part of that reply is a little 3-digit number called a status code.
This is the one you always want to see. If you get a code in the 200s, especially the famous 200 OK, it means everything went perfectly. The server is basically saying, yep, I understood you, I found what you wanted, and here it comes. This is the happy path of the internet.
Ah, and then there's this guy, the infamous 404. We've all seen it. A status code in the 400s means the error was on the client's side. Basically, something was wrong with your request. A 404 not found is just the server's polite way of saying, hey, I understood the address you gave me, but I looked everywhere, and that file just isn't here.
But if you see a code in the 500s, you can relax a little. The problem isn't you, it's the server. A 500 internal server error means your request was probably perfect, but something went terribly wrong on their end. It's the server's way of saying, oops, I think I broke. You know, this basic conversation of request and response has been the backbone of the web since the very beginning. But as websites got more and more complex, with tons of images, scripts, and style sheets, this simple conversation needed to get a whole lot faster.
Back in the day, with HTTP version 1.1, the conversation was very polite, but it was painfully slow. The client would ask for the main HTML file, then it would wait. The server would send it. Then, the client would ask for the CSS file, and would wait again. The server would send it. One request, one response, one at a time. It worked, sure, but for the complex websites we have today, it was a massive bottleneck.
Then HTTP/2 came along and just completely changed the game. Instead of that slow one-by-one chat, the client now opens a single connection and basically asks for everything it needs all at once. The server then just streams all the files back over that same connection, often at the same time. This technique, called multiplexing, was an absolute revolution. It's what allows massive, complex web pages to load in a fraction of a second, and it's why the modern web feels so fast and responsive.
So, from a simple one-at-a-time chat to a lightning-fast, parallel data stream, HTTP has constantly adapted. It's the invisible conversation that builds our digital world, second by second. And that conversation is always, always changing. As our world gets even more complex, you just have to wonder, right? What will the secret language of the web learn to say next?